Hey folks, thought I'd make a video, a couple of the homework problems. In this one, let's see, you were asked to take the top half of the circle, x squared plus y squared equals r squared, and revolve it around the x-axis to determine basically the formula for volume of a sphere. Now we should know the formula for volume of a sphere is 4/3 pi r cubed. So what we're going to do here is we're going to come up with that formula. We're going to verify that really is the formula. So first things first, let me sketch in a representative rectangle. So it looks something like that. The base is delta x. Remember, x squared plus y squared equals r squared is a circle centered at the origin, and it has a radius of r. So we have x-intercepts at negative r, r, and I labeled the y-intercept up there at r just for fun. But when we take this region and we revolve it around the x-axis to produce a sphere, we have to turn the top half of the circle into a function of x. You know, right now it's just a relation, x squared plus y squared equals r squared. So we need to take that, we need to solve it for y, and if we solve it for y, just the top half of the circle is produced by y equals the square root of r squared minus x squared. You'd subtract x squared from both sides. You take the square root of both sides, and we take the square root of both sides. Technically that gives you a plus or minus, but we only need the top half of the circle, so it's just the positive. Square root r squared minus x squared. So here we go. Let's go over here. I'm going to move over here to find the volume. It's just the standard disk method. The representative rectangle is perpendicular to the axis of revolution, and it's resting on or touching the axis of revolution. So disk method, volume equals pi, the integral from negative r to r, square root r squared minus x squared, squared dx. Now before I go any further, I should mention that I could make use of symmetry here because we're symmetric about the y-axis. So it's technically, you know, the top half is an even function. So I could make use of symmetry. I could integrate from 0 to r and then multiply by 2. And I think I'm going to do that here. I think it might just make it a little easier for me. The square root of r squared minus x squared, when you square that, that gives you just r squared minus x squared. We're integrating with respect to x. So now when we integrate with respect to x, you have to keep in mind r is just a constant. I mean, if this circle had a radius of 4, r would be 4. So this would be 16. This would be 16. So when you integrate a 16, you would get 16x. For that reason, when you integrate r squared is a constant. When you integrate that with respect to x, you just get r squared times x. Minus, then the antiderivative of x squared is 1/3 x cubed. Get the limits of integration. So now we toss an r in for the x, r squared times r, that's r cubed, minus 1/3 r cubed. Then when we toss 0 in for the x's, well, we get 0, and we're left with 2 pi. See, r cubed minus 1/3 r cubed, that's a 2/3 r cubed. And when we take 2 pi times 2/3 r cubed, well, 2 times 2/3 gives us the 4/3 pi r cubed, which we recognize that as being the formula for the volume of a sphere. So that's all there is to this one.